So you're all welcome back after a very kind of break in our weekly program due to firstly the Hajj period, and then after that, a couple of personal engagements. Apologies for that. We thank God we are able to come back on live now. So hopefully from now on, we should be able to get some time before we have any other break. So once again, thank you very much for following up, and I do hope that we've been engaging. It's been a very interesting time seeing some of our new members actually leading teams and doing very fantastically well. So especially in the research groups, so people are making a lot of progress. So which is they're making progress, which is very encouraging, and we're all just to also continue to take advantage of such opportunity to improve our knowledge of AI, machine learning, and how we can benefit from it. So today's topic has been carefully selected. Don't forget, we are still on animal, how to improve animal production using AI and machine learning. We still going to come back again. However, due to several questions I've been getting during the break, so I will try to reply to individuals on individual basis. But however, I deem feel that I need to clarify it and bring it up so that everybody can benefit from some of these silent points so that we don't make mistake, especially as we try to dig deeper. It's better we get it right. That's why today's topic is taking benefit of machine learning modeling, irrespective of your backgrounds, irrespective of where you are from, computer science or computer-related fields, engineering, humanity, just mention it. Everybody can benefit from it. So, but today we are more interested in this aspect that is saying, making sure you are doing it right. See, it's one thing to be doing the right thing, but another thing to be doing it right. So machine learning is a good thing. There's no doubt about that. Refer to one of our videos. If you have not checked it, check it out. Why you can no longer ignore AI and machine learning. It is very clear the world is moving in that direction and you cannot afford to be left out. But while implementing machine learning modeling, are you doing it right? Is it the right way to go? So today we are going to share a couple of insights, and then, well, as usual, take a couple of questions if available before we call it a day. So taking benefit of machine learning modeling, irrespective of your background, making sure you are doing it right. So let's move in. Whenever the idea of modeling using machine learning comes to mind, we remind ourselves of this basic principle, and that is the iterative learning nature of machine learning, the iterative nature of machine learning modeling. You see, this is the framework. It's very important that we get it right. So the good news there is you always have this leeway to go in, you see, go inside, do whatever you want to do, and then you can always come back. So you don't always have to get it right at first, because that particular push to always get it right at the first modeling has always led to people missing the insight in the data set. So rather than getting the right thing, getting better, they are getting bad results because they are not doing it right. They are not doing it right. They are doing a good thing. Yeah, they have selected a nice topic and they are making a lot of effort, but they are not doing it right. So we have to make sure we are doing it right so that together we can be able to obey this principle. I call it, let the data speak. If you jump the gun, then the data, you may not be able to make the data speak with you. That is, you may miss some insight from the data. So how do we ensure that we don't miss insight? Rather, we do it the way it should be done so that you can be able to get the best that is possible out of your modeling. So I've had to help some of our members here to do some review, check their papers, ongoing work and the likes. I've seen common mistakes, common across board. Even several international paper review I do subscribe to, I've seen people making this very huge mistake. For example, somebody just going to normalization without modeling using the original data set. This is not correct. Normalization is a very powerful idea, statistically, whatever we have it. However, we have data set that will not benefit from normalization. That once you normalize the data, silent information is hidden, and then you are not going to be able to get the best you are supposed to get. Therefore, we have to make sure that we follow this procedure in a proper way. So, which is what we call let the data speak. Now, let's look at this concept we mentioned before, and I share videos on this. There are different angles that you want to get yourself introduced to this concept. See, these are different angles to solving problems using AI-based solutions. I categorize them into two. The first being to the people from diverse background. See, you are not in computer science. You have no relationships whatsoever with computing or programming and the likes. So you're also welcome. It can work for you. What you need to do is to clearly think and brainstorm about your area of specialization or interest and see how you could utilize ML modeling towards improved outcomes. And further think of how you can improve upon your earlier achievement through coming up with more advanced ML algorithm or techniques like hybrid or ensemble modeling. See, the first thing is to think about a quick one. And usually at the beginning, your first paper in machine learning modeling, don't make it too complicated. Choose a very simple idea and make it go as fast as possible, because that is going to be a big motivation for you. Get it out there. Let the reviewers start doing their job while you keep thinking about some other ideas. Because machine learning is better learned by practicing, through practicing. You have to keep practicing. That's why get your hands dirty with hands-on experience, practice it, get online data set. Later, you can think of how can I get my own data set from my laboratory or from my farm, as the case may be, or from the community you are living. So while the first one is successfully done, which we are going to describe how you are going to do it or how you should do it, you keep thinking of other ideas. In fact, as a good researcher, by the time before you are done with the first paper, a lot of ideas will be coming to your head. Oh, I could have done it this way. Oh, maybe I can include this. But remember, research has to be time-bound. So that is why we are going to have what we call fence in and fence out. Fence in and fence out. Fence out. Fence in are those ideas that are coming to your head as you are doing your work, and you can still include them in your work, present work. They are called fence in. But fence out, they are very similar idea, but because of time or whatever constraint, it's not possible to put them in the current work. You push it further. Next work, we are going to do this one. And we'll come back again later to put more effort on this, how you can link it with the gap you have identified in literatures and also for others. Come back to that. However, to the people from computing science related background, so you think and brainstorm about area that may be in dire need of improved outcome if provided with ML modeling capabilities, and then you step in. You have the solution at your hand, in your hand. People are looking up to you. Today, computing is the pivot of the world civilization. Everything starts to revolve around it. So further think of how you can improve upon your earlier achievements through producing more advanced ML algorithm-based solution or techniques like hybrid or ensemble. And you can even think of developing new machine learning algorithms, new hybrid framework previously unknown. These are possibilities, and you can actually do that. These are from the two points of view that we can look at it. Those people from diverse background and people from computing. And you can have a synergy. You can work together. See, where the people from diverse background, they have more knowledge of those areas, then you synchronize with them, and then you'll be able to work together to get a very huge contribution to the work. Now let's move to let's go back now, return back to make sure that you're doing it right. So the moment you have your data set, the moment your data set is there, you have here data preparation, feature engineering. All these things are labeled data. Anything that has to do with data, manipulating. We have a lot of options for you. This is data consolidation. This is data reduction. This is data cleaning. This is data transformation. All these, you have opportunity to always come back to it later. You don't just have to do everything at the beginning. This is the mistake some people are making. They believe that they have to do everything from the beginning. I'm going to do normalization. I'm going to do this. I'm going to do... At the end of the day, they ended up having mutilated data. I call it mutilated data. That is, the data is now far, far away from the natural data set you collected. This is not the way to go. We want our data to be as close to the natural one as possible. Because the data you are going to be using the live predictive solution for, they are live data. So the lesser the pre-processing you subject your training data to, the better. Because you still have to also subject the new samples to all the pre-processing you are subjecting your training set to before you're able to make good prediction. So it means the more the number of pre-processing stages you pass through, the more the trouble also you have to, because if you don't do that, the new sample is now totally different from what you are trained your model with, because it has undergone normalization, this, and that. So many pre-processing. We don't do that. What you do the pre-processing that is minimum, that is compulsory, and move on and do your modeling. So once you get the data is ready, it's in column wise, you have the target and then the input. Oh, there may be noise, leave it for now. Oh, maybe we need normalization, leave it for now. The only thing you do in the pre-processing stage is what will stop your modeling in case you don't do it. And usually we can see like missing values. If you have missing value, you see, under data cleaning, missing value is one of the most important. And it's also not compulsory. It depends on the algorithm you are using. If you are going to use algorithm like decision tree can work, can model your data without treating missing value because it has inbuilt missing value handling techniques or capability. So in that case, if it is decision tree, you can just ignore the missing value and continue to do your modeling. However, there are a few algorithms like support vector machine that will not work if there's missing value. The algorithm will just stop working. So you need to treat the missing value. That is why we only accept that in majority of situations, missing value treatment may be considered compulsory. So once you have done the missing value treatment, every other pre-processing becomes optional for you. So go into data modeling, select the algorithm, and then do your data modeling. Go into performance measure. Check your performance. If it is classification, check the accuracy. If it is accuracy, the confusion matrix. But if it is regression problem, you'll be checking root mean square error, correlation coefficient, and also for that. Check it. Is the performance within the range you are looking for? Are you getting excellent work, excellent results, or very good work that you are the first in this area? Maybe Even sometimes getting 75 may be highly celebrated. We've had it before. We had an engineering problem solving. Our initial result was getting like 74. We were just starting. Then we told the collaborators, okay, we need to improve upon this. He said, what's the current result? We said 74%. He said, this is super huge. That is enough for them for now. Because the best they were able to get using statistical modeling was just 30-something%. That 70-something is a huge improvement. They are ready to report it at that point in time. That later in future, we will improve upon it as you wish. So it means just by doing simple missing value treatment, and if there's no missing value treatment, just go ahead and do your modeling and check the performance. However, you usually in the first run, I can say this one is very, very important. You go back here, at least to do the hyperparameter optimization. This is it. Hyperparameter optimization or hyperparameter tuning. You have to check it. This is compulsory. See, especially if you are going to compare algorithms. Another mistake people do make, we have seen people, once they use an algorithm A, using the default parameters or hyperparameters, they use algorithm B using default hyperparameter values, and algorithm A is getting 90%, B is getting 85%, they declare the result, that they compare, that, okay, algorithm A is better than B. This is not correct. You don't use default hyperparameter to judge the performance of an algorithm. Let's take note of this. Default parameter varies. So once you have a default parameter, different data set will respond to different default hyperparameter of an algorithm. Therefore, hyperparameter optimization is a must. You must do it. Before you declare algorithm A is better than B on this particular data modeling, you have to carry out the hyperparameter optimization. Let us take note of this. It is compulsory. For example, you are using k-nearest neighbor. You are using k-nearest neighbor, KNN, and then with k is equal to 1, which is the default hyperparameter for k, for the value of k, number of neighbors, and you happen to get 90-something, you don't stop. You keep checking. Check k is equal to 2, k is equal to 3. Keep changing it, depending on the problem you are solving. If it is a binary classification problem, you make sure that k is 1, 3. They are odd numbers. Then you record the best result. Usually, if you get 90, maybe 1 is the best. You have a small plot. Later, you see it go down. You know that this is the best for me, and then you can select it and declare it. Okay, k is equal to 1. But you will not stop. For the second one, maybe I'm using support vector machine as the second algorithm. I have to also do, maybe the default hyperparameter is polynomial. Polynomial kernel may not work for that data. That's why it's getting 80%. And KNN is getting 95. You have to check for other hyperparameter values for SVM, polynomial, Gaussian, and also for that. You have to check for the value of C, the regularization factor C. Once you are done, then you pick the best. Maybe later you find out that after the hyperparameter, SVM may be having maybe 99%, and KNN is stuck at its own 95% initially. So, and you are going to declare KNN as 95 as the best because you didn't do hyperparameter for KNN. You are, by chance, the default hyperparameter for KNN gave you the best result. But for support vector machine, it doesn't. So your comparison is not valid. Let us take note of this. So you have to go, but what we are saying in SN is at least you have to go back here one time to do the hyperparameter optimization. The first time was default hyperparameter, k is 1. Go back, check it for 3. If it is binary classification, check it for 5, check it for 7. Keep doing that until the result go from good and then it started going bad. Then you stop. You identify the hyperparameters that give you the best result, and then you go to the next algorithm, and you also start with default, check the result, and you keep changing the hyperparameter until you get the hyperparameter value that achieve better result. This is what you have to do. This is the minimum. And this is the only area that is compulsory for you to go back to do hyperparameter optimization. Once you check the result, you do your hyperparameter optimization. However, while doing this hyperparameter optimization, you must remember that you don't use your test set for this. You only use the training set while doing hyperparameter optimization. This is another mistake that people often make. They start using test set to check the performance for every hyperparameter. This is not correct. It can lead to a problem that we refer to as data leakage. Data leakage. Data leakage. That is, you are indirectly leaking your data to the training set because you did training and you use the testing set to check and it's not working fine. You go back and change the hyperparameter. So indirectly, you are going to always stop when the testing set is okay. So you are leaking your data to the system. That's why testing set has to be kept totally outside the training and what the validation procedure. Another thing to take note. Number one, it is compulsory. You must do hyperparameter optimization for every algorithm that you want to use in order to make your comparison to be valid. Otherwise, your comparison is not valid. So let us take note of this. So this is very, very important. So that will make sure that the comparison you are having is valid and reasonable. That is the first thing you handle, and it is compulsory. So the only thing that is compulsory for you to go back is to do the hyperparameter optimization. Every other thing is optional. All this going back. Sometimes you have to go back again to change the algorithm. That is it here. You can see it here. I mentioned it here. You may have to go back to change the algorithm. Maybe after the hyperparameter optimization for KNN and support vector machine, you are looking for like maybe 98, 97% accuracy. You're only getting like 60, 70. And you have done all the hyperparameter optimization. You may quickly go back and then change the algorithm again. Maybe they just don't understand the insight in that data. Pick other one, decision tree, neural network. You may have to go maybe deep learning and other algorithm. In the worst scenario, when things gets really tough, you might have to try to make ensembles. You make ensembles. Making hybrids. Just you are still within air. So it means going back to this is the priority to get things right. Don't immediately think of going back. You do that later. You only do that when you are unable to solve your challenge using this recursive level. Because the more you go back, more work will have to be done. You see? So it is when some of these things have failed. Of course, we don't forget the principle that you start simple. You start simple. So here also could be flexible. I want to start with simple algorithm before I start going to complicated algorithm. So let me for now assume that let us leave this one down. Let's leave it for now. Making ensemble and making hybrid. Let's leave it until you're able to do some other little, because making ensemble is very tough. It takes a lot of time, effort, and memory space. So there are some pre-processing activities that may make your work better, that are easier to do compared to building ensemble. So that's why I say, okay, for now, let us assume once you have changed the algorithm, you have done the hyperparameter optimization, and that algorithm is not yet satisfying you, change to other simple algorithm, decision tree, single algorithm, neural network, support vector machine, even though they are a little bit more sophisticated, but they are not as tough as making ensemble. If none of the single algorithms are working, is working for you, none of them, you have tried many of them, they didn't work for you, then at that point, you may start thinking of going back. Because what we are targeting is we want to improve the performance of our model. So we can go back. You have exhausted going back here partially before, because You have only done hyperparameter optimization, which is compulsory. You must do it. Even if you get the best result from default parameter, you have to do the hyperparameter, because how are you sure that another value of the hyperparameter will not give you a better result than what you are getting? Especially when you want to compare. Most likely you can't get good result for all the default parameter of different algorithms. One default algorithm A may give you good work. The second one may not work with the default hyperparameter. So you have to check the hyperparameter optimization. It's compulsory. You must do it. Then if nothing changes, then you keep changing the algorithm. If you have exhausted all the possible algorithm within your reach, then maybe it is time for you to go back. Don't go to the ensemble and host of others yet. If there are simple preprocessing you can do, why not? So let's go back. Remember, we have only undo missing value. See, we may now try to say, okay, maybe there's noise in the data. Can we reduce the noise? Can we reduce the noise? See, no, there are some noisy data. There are methods to reduce noise. Or let me start with the one that is common to everybody. Normalization is part of data transformation. Normalization is not data cleaning. This is data cleaning. Why? This is called data transformation. There are 4 major things we do under data preprocessing. We have data consolidation, we have data reduction, we have data cleaning, and we have data transformation. So you go, depending on the problem you are solving, you decide to, okay, which one should I do? And that's why expert is very important, because of experience. You solve problem with experience. So you now say, okay, which one will work, which one may work. So let's do normalization. Everybody is used to normalization. So you bring in normalization. Normalize your data. Once you normalize your data, then go inside again. Do the data modeling. Using your k-nearest neighbor, using your support vector, using all the single algorithm you have used before. Let's see what performance you are going to get. Maybe your performance improved. Wow, you can celebrate. We have seen cases where normalization solved the problem. And you don't need to go back again, because there are so many other preprocessing stages we can do. We are going to be taking them gradually as we move on for better understanding and clarity, inshallah. So once you are done with normalization, then you do your data modeling. Then there are the performance measure, check it. And then in this, after that, you know, there's something I say it's always compulsory. This hyperparameter optimization. If your normalization, your normalized data is working with the original hyperparameter value you have done before, that is fine. Sometimes the hyperparameter values you search for using the original data may not work for the normalized data, which means you may have to repeat the hyperparameter optimization. And that is why data science project is better done in a group, because there are so many activities you need to carry out. And time is also not on your side. Your outcome need to go to the world quickly. So that's why the more the people around you who are ready to work, the better. You do it as a team. So one is working on the original data set, another one is looking at the normalized data set, so that they can easily do the hyperparameter optimization repeatedly, as the case may be. However, if with the earlier done hyperparameter optimization, your normalized data is doing fine with it, that is okay. But sometimes it doesn't, it's even worse. You can't conclude that the normalized data is not good. You go back and do hyperparameter optimization. Maybe it's because you have normalized the data, everything has been changed from big value to between 0 and 1, between -5 and +5. There are different types of normalization. Because the question that will arise is, which type of normalization should I use? And that is again why, if you have a team, one team member can investigate one type of normalization. I've had it before, that different normalization produce different results. That is data science for you, and that is the need for, there is need to let the data speak. So if you do one and just conclude, this is my best, you may actually be showing people not your best, but the one you decided to present, because you didn't give the system opportunity to let the data speak. So now what we have done today, now we have said that you have original data. Always let us pay attention to that. Original data, the original data. Now we are also working on normalized data. Normalized data. Take note of that. Original data. Then you can compare the result of the original data with the normalized data and see which one is better for you. That is after you have done the hyperparameter optimization for the original, which is compulsory. Use the one you use for original for the normalized data. If it works for it, that's okay. But sometimes it doesn't work. It means you have to do another hyperparameter optimization for the normalized data. Because normalized data is like a totally different data. After this, you compare the two. The mistake people often made, I know that no one will do that again, is people just start with data, normalize it before they do any modeling. And then they normalize the data and they were not able to get good result. And they keep trying. They build ensemble. They build so many powerful systems. Nothing works for them. And I got to know about this problem and I said, where is the original data? Because looking at the data, it doesn't look original. He said, we normalize it immediately we got the data. I said, no. Did you carry out any modeling using original data? They said, no. I said, this is not correct. You need to let the data speak. That is the principle. Use the original data set first, put the results in a place, use the normalized data set, and then compare side by side. Whichever one works for you, that's what you are going to declare. And that is in line with the principle of letting the data speak. And after they decide to do that, surprisingly, the original data actually achieve better result than the normalized data. You can see. So we have encountered several scenarios. We have seen normalized data performing better than original, and we have seen original data set in its normal form performing better than the normalized data. So we have to bear this in mind once when we are doing our modeling so that we don't miss important information. So once that is done, let's take note of this. This is two versions of the data set now, original and the normalized. There are still other options we are going to discuss on this topic of making sure you are doing it right. So I want to believe it's a good place for me to stop for the day so that we can take few questions if available and allow you to also digest it and then understand it. This is how we are going to be going back to each of the options of improving our data. When things don't go after the normalization, we still don't get good result that we're expecting, we go back again. Maybe we need to do something. Maybe we need to identify and reduce the noise in the data. Maybe we need to come up with new features. Maybe we need to select features and some other stuff we are going to do. Like I said again, let's take it gradually, so that we can all ensure that we are doing it right. And for those who are already modeling, let us look into the modeling. Always let the result of original data be available, and then the result of normalized data. Normalization is very common. Once people get data, they normalize it. No, don't normalize the data. Use the original data as it is. Then normalize later if there is need for it. If there is need for it, you normalize it. Sometimes you don't need the normalization. The original data is working. Let it go. And also further considerations that we may be considering as we are going to continue on this particular same topic. Hopefully next time. Thank you very much once again for listening. And we're going to take a couple of questions before we call it a day. Thank you very much.